Let's look at two examples that we're going to rationalize our denominator. So anytime that you have a fraction with a radical in the bottom, it's not considered completely simplified. In order to get rid of that radical in the bottom, you can multiply by the square root of that number. So the square root of 2 times the square root of 2 in the bottom, and then whatever you do to the bottom, you also have to do to the top. So I'm also going to multiply by the square root of 2. Now I'm just going to multiply straight across as if these were fractions. 3 times the square root of 2 is 3 square roots of 2. The square root of 2 times the square root of 2 is the square root of 2 times 2. The numerator is going to stay, and then 2 times 2 under that square root is going to simplify to 2. When you simplify to this point, you want to check that the numbers on the outside of the radical can't simplify anymore, and 3 over 2 is completely simplified. So that is my final answer here. Now let's look at another one. I have the square root of 4 over 6. First thing I'm going to do is simplify 4 divided by 6, and that's going to become 2 over 3, since both of those numbers are divisible by 2. Okay. The square root of 2/3 is the same as saying the square root of 2 over the square root of 3. Now because of the square root of 3 in the denominator, I'm going to multiply both top and bottom by the square root of 3. When I multiply across on the top, I get the square root of 2 times 3. And in the bottom, I get the square root of 3 times 3. The square root of 2 times 3 will simplify to the square root of 6. And then the square root of 3 times 3 will simplify to 3. Because my numerator is under the square root and my denominator is not, this is completely simplified here.